When you look at a map of India, have you ever just stopped and wondered, how did it get that shape? It's not just random. It's an absolutely epic geological story. We're talking fire, ice, a collision of continents. It's incredible. So let's dive in and unpack the story of how this subcontinent was forged.
Okay, so our story really starts with two big questions. First one, why does India have the world's tallest mountains? I mean, the Himalayas are just colossal. How did they even get there?
And the second question is tied to that. Why do almost all of its great rivers, the Ganga, the Godavari, why do they all flow in pretty much the same direction? It seems a little weird, right? Well, the answer to both of these questions is all wrapped up in the absolutely wild journey of a single tectonic plate.
All right, to really get this, we have to rewind the clock. Way back. We're talking millions of years ago. And we're not just going back in time. We're going way, way south. Because believe it or not, India didn't even start out in the northern hemisphere. So picture this. The piece of land that would become India was actually part of a giant supercontinent called Gondwana, and it was way down near the Antarctic Circle. So forget everything you know about India's climate now. Back then, it was a cold, vast place, probably covered in massive glaciers. But here's the thing, it was starting to move. Okay, so as this plate starts drifting north, it hits warmer and warmer latitudes. And what happens when you move ice into a warmer place? It melts, right? So these enormous glaciers started melting, creating this huge flood of fresh water. This water just swamped all the forests, burying plants and trees. And then, over millions and millions of years, all that submerged vegetation got compressed. And voila! That's how India got its massive Gondwana coal deposits. But here's a little mystery for you. Why is almost all of that coal found in eastern India? Like in places like Jharkhand and Odisha? Well, there's a reason for that. And it's because the western side of the plate, well, it was about to have a very, very fiery encounter. We're talking an event that would bury anything and everything under miles of molten lava. So, as the plate keeps trucking along on its journey north, it drifts over some of the hottest, most active spots on the planet. And these encounters, they were going to leave a permanent scar on the land. This is all because of something called hotspot volcanism. The best way to think about it is like this. Imagine a giant, permanent blowtorch sitting deep inside the Earth. It doesn't move, but the Earth's plates, they slide right over it. And as the Indian plate crawled over this blowtorch, the super hot magma just burned right through the crust and poured lava all over the surface. And it turns out India actually passed over two of these things. First was the Kerguelen hotspot, which gave us the Raj Mahal traps in the east. But the real showstopper? That was the Reunion hotspot. As the western half of the plate slowly ground its way over that, it triggered these unbelievably massive eruptions. And that's what created the famous Deccan traps. Those huge step-like layers of basalt rock that you see all over western and central India? Okay, so after millions of years of drifting, getting flooded, and then scorched by volcanoes, the Indian plate is finally nearing the end of its journey. And this is the main event, the grand finale. We're talking about a slow-motion, head-on collision with the entire continent of Asia.
Now, the first hit wasn't actually continent on continent. It was what geologists call an ocean-continent collision. See, before India could hit Asia proper, it had to crunch through the ocean floor of the old Tethys Sea. And that pressure was just immense. It literally buckled and folded the seabed, pushing it up and up, creating the very first mountain range, the Trans-Himalayas. That includes ranges like the Karakoram.
But the plate didn't stop. It just kept pushing forward. And that's when the real collision happened. Continent smashing into continent. It's a crash that's been happening in super slow motion for millions of years. And the Himalayas didn't just pop up overnight, they rose in stages. First, about 60 or 70 million years ago, you get the Himadri, the Great Himalayas. Then, way later, the Himachal, or Lesser Himalayas. And finally, the baby of the family, the Shivalik Range, which is the youngest of them all.
So this crash, it did a lot more than just build mountains. It literally bent, broke, and tilted the entire Indian subcontinent. It's the reason the landscape looks the way it does today. And the way it happened is just fascinating. See, the plate didn't hit Eurasia straight on. It hit the northwestern corner first, and the force of that initial impact was so powerful, it basically shattered the western coastline, making it break off and sink into the ocean. But that's not all. This lopsided impact also forced the whole plate to tilt. Imagine lifting one corner of a dinner tray. The northwest side went up, and the southeast side dipped down.
And that, right there, is the answer to our second question from the beginning.
That tilt is exactly why most of India's big rivers, like the Godavari and the Ganga, start in the high ground in the west and flow downhill towards the east, right into the Bay of Bengal. It all clicks into place, doesn't it?
The collision also did something else that's pretty wild. As the plate shoved its way into Asia, it kind of pivoted around two really solid points. And as it did that, the whole Himalayan mountain range was forced to bend around them, creating these two super sharp hairpin turns. Geologists call them syntaxial bends.
So get this, one single event, this collision, ended up creating two totally different coastlines. On the west, where the land literally broke off and sank, you have a narrow, rugged, what's called a submergent coast. But on the east, the side that just gently tilted down, you get the opposite, a broad, flat, emergent coast, where rivers have been dumping sediment for ages, creating huge deltas.
Okay, let's pull all these pieces together. We've got a journey from the South Pole, a fiery passage over hotspots, and one heck of a collision. And all of that action is what created the 5 major physical regions of India that we see today. There's one more piece to the puzzle. As the Indian plate keeps diving under the Eurasian plate, it creates a kind of long, shallow ditch or trough just south of the new mountains. So for millions of years, the rivers pouring out of the Himalayas have been filling that ditch with tons and tons of sediment. And that is how the vast, flat, and super fertile Indo-Gangetic plains were born. They're actually the youngest major part of India's landscape.
And there you go. The whole story is basically written right on India's map. It starts with the Peninsular Plateau. That's the original ancient piece of Gondwana, so it's the oldest part. Then you have the collision which built the young, still growing Himalayas. That same collision created the 2 different coastal plains. And finally, you get the trough that filled up to become the Indo-Gangetic plains, the youngest piece of the whole puzzle.
So, one absolutely incredible journey resulted in these 5 distinct geographic zones that make up the subcontinent. It's amazing, really. From the oldest chunk of rock to the youngest river plains, every single feature tells a piece of this incredible story.
And you know, the story isn't over. The Indian plate is still pushing north right now, and the Himalayas are still getting taller, bit by bit, every year. This ancient geological engine built the India we know. So it really makes you wonder, what forces, geological, climatic, and even human, are shaping the India of tomorrow?